So I wanted to do another example where we apply the state transition equations. But this time I wanted to do it on a system where we have, let's say, an absorbing state or two. Okay. So I'm going to put an absorbing state there and there. And we'll let our probabilities sort of run around like that. Okay, so let's put some values here. Of course, we have 1 and 1 here. And we'll say this is 0.5, 0.5, 0.5. Oh, then that has to be 0.5. Well, let's make it a little different. We'll do this 0.7, 0.3. I'll make that 0.25, 0.45. What does that give me? 70. And I think that needs to be 0.3. Okay, so let's see what happens. So we'll call this state 1, 2, and 3. And then these absorbing states will be states 4 and 5. All right. So again, this is a good exercise to sort of practice figuring out what our transition matrix or one-step transition probability matrix is. And so let's go ahead and do that. So for state 1, oh, and actually, why don't we, yeah, we'll do that. We'll just keep it like that. State 1 does not go to itself, but it does go to state 2. It does not go to state 3, but it does go to state 4. So we get 0, 0.5, 0, 0.5. For state 2, it goes to state 1 with probability 0.7. Whoa. 0 to itself, 0.3 to 3, and that should be it. All right, for state 3, we have 0.45, 0, oh, no. We have 0.3, 0, 0, 0.25. And then for state 4, 0, 0, 0, 1, 0. And finally for state 5, 0, 0, 0, 0, 1. Okay, so this is our n-step probability matrix. So what I want to do is I want to show what happens, let's say, if you start in state 1. What happens? What happens if you start in state 2? Oops. And we indicate that by A1 in the second term. What happens if we start in state 3? No, 3, 4, 5, yeah. One too many zeros. Okay. And again, if we started in state 4, where would we end up? And if we started in state 5. And so what we're going to ask ourselves, what is U of, let's say, 10, given one of these U zeros, okay? So, and again, so this is the first case where we start in state 1, right here. Let me actually draw that differently. So this is starting in state 1, this is starting in state 2, starting in state 3, starting in state 4, and starting in state 5. All right. So let's go ahead and quickly calculate those probabilities. Again, all we need to do is take, since we're doing the 10-step 10 transition, or 10 steps, we take p to the 10th power, and then we multiply it times whatever u0 is. All right. So the first step that I'm going to do is I'm going to type in our p matrix into Octave. And again, just go row by row. So 0, 0.5, 0, 0.5, 0, 0.7, 0, 0.3, 0, 0, 0.45, 0.3. And actually, if you want to know a little trick, let's see, you can press return, and it knows, you know, sort of to go to the next line. If you want to do that earlier, just to make life, oops, I'm going to type this again. Let's say you wanted to make life a little bit easier. Oh, it didn't let me do it. How surprising. Okay, hold on. I'm going to clear and close this all out. So if you want to make it a little bit easier, I know in Octave you can do this. I think in MATLAB you can as well. So after each semicolon you can press return, and when you close the bracket it will know. So this way it's a little bit easier to keep track of each line. Semicolon. 0.45, 3, 0, 0, 0.25. Okay, so now I'm going to close it off, and you'll see it actually filled out this P matrix. Okay, so if we want to check that, in fact, we did the right thing, we can sum across P. I think we can, no, sum across the first dimension. No, that's not what we want. We want to sum across the rows. So when I did this, I'm summing across the columns. Columns are the second dimension, so I'm going to sum across this way. And so, in fact, we know I typed in P correctly and that I generated it correctly because each of the rows adds up to 1. So that's what I did here. Okay. So we have our P matrix. And so what we were going to do is we're going to say, well, let's test different starting conditions. So for this first case, we're starting in the first state. And so we can say u to the 10 is equal to P up 10 transpose times, and in fact, I'm not even going to do u0, I'm just going to do it this way. Right. So this is the initial start matrix. It'd be like if I had typed in u0. So I could do this, right? That would certainly work. But the way I'm going to do it, because I'm going to keep changing the values, I'm going to type it in like this. Okay. All right. So if I start in the first step, the first state. So let's say I started in the first state. Then u of 10, again, I just plug it in. So you would do this on your calculator. You would tell me, you know, what u of 0 is. You would write this whole equation down, and then you'd say that's going to be equal to u10. And then all you'd have to do is give me the numbers. So you don't have to, you know, it's just multiplication at this point. And certainly you don't even need to go to as many digits as I'm going to. I'm actually going to start rounding to 4 digits. One, two, three, four. All of them got rounded up somehow. Oh, 5, 3, 5. 1, 2, 3, 4. 1, 2, 3, 4. Okay, yeah, maybe not. Okay. Alright, so this is what happens if we start in state 1. Okay, now let's ask ourselves, well, what if we started in state 2 initially? Where might we be after 10 steps? Alright, so if you ever want to retype in an equation without retyping it, you can just press the up key. Alright, and it will remember or retype the equation for you that you already typed. So I'm just going to change this to 0, 1, 0, 0. Alright. And do the calculation. So now I have my answer pretty quickly. So 2219. Oh, no, sorry. 0.0222. 0.0218. 0.007. 0. I think is that what we got? Yeah. And then 8041 and 14 ends up getting rounded. Wow, Is that right? Something like that? Maybe I'm bad at rounding, but... Okay, so what we can see is we get a different answer, okay, but not too far away. Let's see what happens if we start in state 3 now. Okay, so I'm going to get rid of the 1 there. I'll put the 1 there. And we get 0.0196, 0.0168, 0.0066, 0.6333, 3237. Okay, so this actually looks pretty different, right? I mean, these values here are kind of a bit different from these guys. Right? So we do see where you start affects where you'll be in 10 steps. Now, let's say you started at state 4 or 5. Now, the answer should be pretty easy. I shouldn't even have to do any calculations, but I'm going to do them anyways. So the answer, we know that state 4 is an absorbing state. So if you start in state 4, you're not going to leave state 4. So that means after 10 steps, we should get back 0, 0, 0, 1, 0. You are guaranteed to still be in state 4 after 10 steps. All right, let's do the same thing with state 5. And we should expect to get back 0, 0, 0, 1. All right, so let's see that happen. So if we started in state 4, then we have a 1 here. And sure enough, we get a 1 back. All right, let's see if we started in state 5. Sure enough, we get a 1 back, just as we expected. And we can look at the n-step transition matrix. All right. So let's take p to the 10th power. In fact, we'll learn a little trick here. That was kind of explained it, but I'll just bears repeating. So I'm going to write down what this matrix is. Okay. Let's sort of see. We got, and I'm just going to do a lot of rounding here because the exact values don't matter. It's more the idea. Mm, 0.012, 0.022, 0.017. 0. So some of these values actually look really familiar. All right, let's look at this row here. Well, sure enough, that row, so this first row, is the same values that we see here. Of course, I did some rounding, right? Now, let's look at the second row. Sure enough, those values match what we have in here. The third row matches as well, and same with the fourth and fifth row. We see that they're the same values, but just transposed. And it makes sense, right? Because what we are doing when we are taking p to the 10th power transpose, and then we are multiplying it, let's say, by 0, 0, 1, 0, 0, what you do when you actually multiply by a vector with one element that's 1 and all the others are zeros, what you're saying is take out the third row of p to the 10th transpose. Okay. Or third column. Sorry. Is it column? Column. You're actually taking out the third column. Now, taking out the third column, okay, is of this transpose matrix is the same thing as taking out the third row of p to the 10. Okay. So there's a neat little idea. Hopefully, it gives you a little bit of intuition of how probabilities move around, right? So you can see when we can actually kind of logic some of this stuff out. When you started at state 1, I would bet that you're more likely to end up at state 4 than you were at state 5 after a few steps. And actually, let's check that out. So here goes 4, and here goes 5. And sure enough, if you start in state 1, you're way more likely to end up in state 4 than to end up in state 5. Let's see what happens if you compare that. Let's say if you started in state 3. Where are you more likely to end up? You're probably still more likely to end up in state 4, but I bet you the probability of being in state 5 is still much closer. So let's look at that. So before we had 8, 9, and 0.89, so 89 and 7. Okay. Here we see the probability of ending up in state 5 is actually a lot larger. To end, we're going to sort of give a little hint of what we're going to study next. What happens if I take u to the 1,000? Okay, so I want to know after 100,000 time steps, where do I end up? And does it matter where I start? Okay, so let's ask that quick question. So we saw that after 10 steps, depending on whether we started in state 1 or state 3, we were more likely to end up at one of the absorbing states, 4 or 5. So let's see if that's still true after 1,000 time steps. So, all right, so I'm just going to call this u a lot, right? And we're going to take this to 100,000. Okay. We're going to pretend, let's start in state 1. What do we get? All right. And so what the interesting part is that after 100,000 steps, you're going to see that the probability that we're in one of the transient states. So again, these guys here are transient, right? These are transient, while stages 4 and 5, these guys right here, are absorbing states. And so we sort of see this. It's sort of neat. You sort of bounce around in here with randomly, but every now and again you get stuck in state 4 or 5. And the neat part Alright, so let's see this. So if you started in state 1, okay, so let's say, we're going to say you start in state 1, the probability that you end up in state 4 is 92, and the probability that you end up in state 5 is 0.0, let's say 8%, right? And adds up to 1, which is kind of neat, what we expect. Alright, so let's see what happens if you start in state 2. Which one are you more likely to end up in after 100,000 steps? So you end up with about 85% chance that you're in 4 and 15% chance that you end up in state 5. And let's finally do this for states for starting in state 3. So here we get 0.67 and 0.33. So kind of, yeah. So later on down the line, we're going to start asking ourselves, after, let's say we take n to the infinity, what is going to be our distribution? What state are we most likely to be in? Or what is the distribution of states that we might be in? And so this is where we'll pick up on the next lecture, or next set of videos.